All right, so we were just talking about the corollary between injection points and what you're doing under here under the disable section. I want to go over that a little bit more now that I have a little bit more time and I'm not staring at a cam studio window. I'm still going to bring it up, but 20 seconds in, I got some time, or we have some time. So, in a general sense, the enable section, this whole block under the enable section right here, this is stuff that is executed, assembled, and put into memory as soon as you enable the script. When you disable the script, it has to replace, and more specifically, this injection point right here. Again, you'll see we'll show assembler, see if we can bring it back up. There we go. Nope, don't do that. Do that. So you will see that when we enable the script, this instruction will be overwritten with a jump to wherever our memory is allocated here. And when we disable the script, we are deallocating that memory. So the jump will now point to just nowhere. It'll just point to nothing, just a random chunk of bits, and the application's going to immediately crash. So what you have to do is you have to tell Cheat Engine, here's what you need to put back in this memory location when this script is disabled and my memory is obliterated and my instructions no longer, and my logic and whatever no longer makes any sense. You have to tell Cheat Engine, here is what I want to be put in this memory location. Restore this to some sane instruction. Now, in our case, it's just one instruction, but in more complicated cases, it might include a jump by, in and of itself. It might be, 3 instructions. It's all, we sort of lucked out in the sense that we're only dealing with one instruction for original code here. But rest assured that when you start really messing around with this stuff and creating all kinds of crazy scripts, you're going to rapidly find yourself staring at original code that is 2, 3, 4, 5 lines long and includes jumps, and it gets complicated real quick. So, injection point 1932 EC39. We are going to jump to increase karma. We will execute some logic, which at this point there is none. We will jump to increase karma. It does the same thing as original code. We jump to return increase karma. Execution of the application resumes at the next instruction. And then when we disable the script, it'll go to this memory location, which is the same as where we injected at. It'll take the jump and the NOP and whatever the hell we have up here, whatever padding you need, and it will replace it with move ESI plus E0, comma EAX, which is the original code, and everything will be back to normal and the game will be none the wiser. So at this point, when we enable this script, it will do exactly what the game does right now, which is reduce karma when we click plus and increase karma when we click minus. And then when we disable the script, it will do exactly the same thing. So how do we assign this to our cheat table? It's really easy, or to our instance of Cheat Engine, if you will. Let's go here. We can delete this. I think we're probably way beyond that. You go to File, and you go to Assign to Current Cheat Table, and that's it. Now, if there are massive errors in your script, then Cheat Engine will complain. See if we can, and now we can close that because our script exists. So if you just in case you missed that, it assigned our auto assemble script to our current sort of unnamed anonymous table. If you double click on the value here, it just brings up the script. It's like, hey, here you go. Here's some stuff. Here's some code. Here's some script. Do whatever you want. Click OK. Now, if we have, let's create an intent. We've been very careful, or I've been very careful about our syntax and typing and things like that. Let's make an intentional syntax error and see if Cheat Engine can notice. So let's just add next right there. Hit OK. We get an error. Warning, not all code is injectable. Error in line 8. That's some nice stuff right there. Label entry increase karma X. Entry increase karma X is not defined in the script. Are you sure you want to edit this? No, I am not. So what is Cheat Engine telling us? It's saying that you defined a label up here, entry increase karma X, and you did not actually define any or associate any content or instructions with that label. So it's just sort of floating around out there, and maybe you want to jump to it, maybe you definitely don't want to jump to it, but Cheat Engine is basically telling you, I don't know what this label is, and yet you've told me that you have this label. And so it's doing just a basic sort of logical sanity check over your script. It's not going to get super advanced. Trust me, it's not going to get super advanced. It's just doing a basic sanity check and saying, all right, you sort of declared this label, you define this label, and and that's it. If you declare a label and you don't actually associate or define it in any way down here in your allocated memory, then it's going to complain. Let's see if we can do the opposite. So we're declaring a label, entry increase karma X. Let's just do that. Hit OK. Oh, what do we get? Another error. Entry increase karma is not defined in the script. It's the same sort of error, but it demonstrates that if you declare some label and it is not defined or any content is associated with it in your script, Cheat Engine is basically going to tell you, are you sure you really know what you're doing? Because if you don't, you're going to screw the application and you're going to screw me. So we've gotten rid of the X's there, our intentional errors. We'll hit OK. We'll go back into it and take one final look at it and see what we get. Let's see, enable. We're allocating 4K because that's sort of the basic minimum page size. We're doing label, entry, increase karma. We have our process function. We have our return function. Here's where our allocated memory starts. What do we have inside our allocated memory? We have entry, increase karma, which we declared right here. We're not doing anything inside it. We're just jumping immediately to the process increase karma, which is defined right here and is declared right here. So we know we're safe. What is process increase karma doing? It's moving EAX into ESI plus E0, and then it's immediately jumping back to return increase karma. Where is return increase karma? It's down here. So where's our injection point? At what memory location are we overriding an assembly instruction? It's 1932 EC39. So we'll bring up our assembler here. If we can maybe squeeze in, there we go. 1932 EC39, thank you. When we enable the script, this instruction will be obliterated, and what will happen is that it'll be replaced with a jump and then one NOP, and whenever the application iterates through this whole series of assembly instructions, it will jump over to our script will execute, it'll do all kinds of logic. At this point it won't do a whole lot of or any logic, frankly, but our script will execute, or our entry increase karma and then process increase karma will execute, to be more specific, and then it'll return control immediately back to the application at 1932 EC3F. And then when we disable the script, it'll go to the same memory location that we're injecting at, and it'll restore the original code, as you can see, as evidenced right here in the memory viewer, because we haven't changed anything, with a move ESI plus E0, comma EAX. And then we will obviously get rid of one space there. We will deallocate our memory, because that's just good housekeeping, and if you're not a good housekeeper when it comes to programming and scripts, then you should set yourself on fire. That's frankly how I feel about that. So let's give this a whirl. We don't need this window anymore. Why don't we need this window anymore? Because if we enable this script and we really fuck up, the program's toast. So it's not going to matter what values are or are not in this window. We will completely destroy this application. It will have no hope of recovery. So let's shrink this down. It's getting down to the moment of truth here. Bring this up. I gotta find some way to make them both. There we go. Let's do that. So when we go over here and we will rename this, what is something, we will call it Wire, whatever. If you're into Shadowrun lore, I don't actually know how to pronounce his name, but this guy is in fact the man. He's actually a dragon, but similar to Mr. Dunkelzahn, who was actually assassinated during the presidential election of 2000. Shit, I don't remember the exact year, but anyway, that's neither here nor there. So how do we know that this script is working? When we click active right here, you will see this instruction disappear. and it will be replaced with a jump, a JMP, to some totally arbitrary memory location. And that will be where our script or our chunk 0 is, or it exists. Not so much chunk 0, but certainly where entry increase karma exists. So this memory location 3939 will be replaced with the memory location of entry increase karma, and so control of this, when the game or the application is going through and executing instructions, it'll hit this memory location right here. It'll immediately jump to entry increase karma, which will immediately go to process increase karma, which will do this, and then it will immediately go to jump, or it will immediately go to return increase karma, which is the following instruction after this point, which is that. So hit OK, sanity checks, basic syntax and whatnot. Let's click active. Enough BS. Let's highlight it. 39. Look at that. Look at that. That's something special. 1932 EC 39. Obviously the array of bytes changes. You can see there is in fact a jump instruction. There's some crazy address right here. Who the hell knows where we are in memory? And then there's the essential NOP afterwards, because this is only 1, 2, 3, 4, 5 bytes, and then we need a 6 byte so that we don't confuse the application in the OS. Now, if everything is working, we should be able to go back into the game and click plus, and it'll subtract values. Click minus, it'll add values. There we go. You can see we'll just click 1,000 times. Our script is working. We are jumping to our script. It is executing. And it is doing exactly what the game did before it, except what we are proving at this point is that our structure is correct, our alloc is working, our labels are proper, where our instructions are not crazy, our injection points, are not off by 1, our offsets are proper, we are deallocating memory, and we can just sort of, keep your eye down here on this sort of 3.9 as I go up here and deactivate the script. You can see our disable section, it moves ESI, it moves the original instruction right back into it. You can sort of screw around with it here, do that, and do a bit of that, and a bit of that, and a bit of this, and a wee bit more, and a little less more. There you go. So the game is not crashing. We are seeing no spurious behavior. So let's, again, keep your eye down here. This is the instruction. Let's activate the script. You can see it is replaced by a jump and then a NOP 044A0000. Let's disable it. Let's re-enable it. 044A000. Let's do it again. Let's do it again. Do it again. Do it again. Let's just click it out, I don't know, a couple times. Or a lot more than a couple, but certainly a bunch. And you can see that the game is in fact still functioning. You can be more than confident at this point that the basic structure of the script is solid and that we are not totally talking out of our ass. And we are going to sort of stop it here, and we will start commenting out and then messing around with some of the actual assembly instructions that are going on in the next video.